Welcome to the On-Site Power Systems UC Davis Biogas Energy Project, an advanced technology that will take organic waste and create sources of renewable energy and biofuels that will help reduce our state's and country's reliance on foreign oil. The Biogas Energy Project demonstrates an advanced anaerobic digester technology capable of processing high solid and high liquid organic waste streams. The advantage of this system is that typical digesters can only handle high liquid waste streams, and this system can handle high solids including grass clippings, food waste, without any type of pre-processing. The material goes through two stages in the anaerobic digestion process. The first stage breaks down the material and makes water and organic acids. The second stage takes those organic acids and creates methane gas. The two stages of the digestion process have different types of bacteria strains. The first process, the bacteria is very hardy and lives in almost any environment, where the second bacteria that makes the methane gas is very sensitive to temperature and pH. This process separates those two stages, allowing each bacteria phase to have the best environment. So the way the system would work is we would load the organic materials into a tank, allow it to break down at its own speed, its own rate, its own temperature, its own pH. As material breaks down, it generates water and organic acids. We take the water from the tank and decant it and feed it to a second tank where the bacteria that makes the methane gas is housed. In that tank, or the gasification tank, we keep the optimal environment for the bacteria, 135 degrees Fahrenheit and a neutral pH level. On regular intervals, we'll take water from one of the first stage tanks where the solids are with the organic acids and feed it on a very controlled level to the gasification tank. And with this approach, we make a very steady, even production of biogas. Typically, food waste will break down in 5 to 7 days, green waste in 10 to 12 days. And we let the material stay there as it breaks down and creates the water and the acids, and then we feed it to the gasification tank. What we're able to do then is load the material as it's collected right into one of the first stage tanks. For instance, green waste takes about 12 days to break down to get the most energy out of it. So we'll load the one tank with 3 days worth of green waste, let it sit there and break down. Then we go to a second tank and load the next 3 days worth of material, a third tank and a fourth. So now we have a batch loading process. Each tank is in a different stage of breaking down and making organic acids. Besides biohydrogen being produced in the first stage tank, we do produce some biogas. But the bulk of the biogas is produced in the second stage tank, or the biogasification tank. We collect all the biogas produced in the first stage tanks, blend it with the biogasification tank, and we have a nice even stream of biogas produced, typically 65 to 70% methane. The gas is then collected and cleaned. We go through H2S removal, and we remove the moisture from the gas. Once the biogas is cleaned up, it can be used to power an on-site generator, creating sources of renewable energy. Can be used to power a boiler to offset natural gas use, or can be converted to multiple vehicle fuels. As this technology developed through an alliance between UC Davis and On-Site Power Systems goes to the market, it will provide a safe and viable solution to the growing amount of organic waste generated throughout the world, providing renewable green energy and fuel for a cleaner, sustainable future.